Beneath the infinite expanse of a starry night, we begin the story of Nathaniel Bowditch, the self-taught genius known as the mathematician who coded the sea. This presentation explores Bowditch's profound impact on maritime history and the democratization of American science. By correcting flawed nautical tables and simplifying complex celestial mechanics, he empowered sailors of all ranks to navigate the world's oceans with unprecedented precision. Against a backdrop of the deep sea and the tools of his trade, we examine how one man's commitment to mathematical truth bridged the gap between elite academia and practical utility, forever changing the course of navigation and scientific accessibility. Nathaniel Bowditch was a pioneer who bridged the heavens and the earth, translating elite theoretical science into practical tools for a developing nation. His genius reshaped three vital institutions. First, he re-engineered global navigation, empowering every sailor to plot precise coordinates and ensuring maritime safety. Second, he made academic astronomy accessible, turning complex celestial mechanics into a pedagogical masterwork. Finally, Bowditch applied the rigorous logic of the stars to modern finance, establishing America's first actuarial and life insurance frameworks. Through these contributions, he proved that the most profound mathematical truths are those that can be applied to the risks and realities of everyday life. Nathaniel Bowditch's journey began within the architecture of adversity. Following a devastating 1775 shipwreck that ruined his family, his early life was defined by grueling labor and scarcity. At just 6 years old, he carried heavy shovels of hot coals to keep the family fire alive. By 10, he abandoned his education to work in his father's struggling cooperage. The pivotal turn came at age 12 with a 9-year indenture as a bookkeeping clerk. Immersed in a ship chandlery, he traded manual toil for the rigorous discipline of the ledger. Here, amidst compasses and shipping logs, Bowditch mastered the mathematical exactitude that would later define his legacy, proving that his genius was tempered by the very hardships he endured. Denied a formal education, Nathaniel Bowditch set out to decode the universe by reverse engineering scientific knowledge through dictionaries and translated Bibles. His self-directed timeline is staggering, teaching himself algebra in 1787, mastering calculus by 1789, and unlocking Newton's Principia Mathematica in 1790, where he notably identified an error in the great scientist's own math. The catalyst for his ascent was gaining access in 1791 to the Salem Philosophical Library, a captured collection originally belonging to Irish chemist Richard Kirwan. There, the 18-year-old hand-copied elite scientific transactions. By 1792, his mastery of French unlocked the works of Enlightenment mathematicians, leading him directly to Laplace's Mécanique, Céleste, and a future of profound scientific contribution. Over 9 years, the Atlantic and Indian Ocean served as Nathaniel Bowditch's laboratory of the sea, where he tested theoretical mathematics against the erratic variables of the open water. His 1795 voyage to Réunion yielded simplified lunar distance formulas. In 1796, sailing to Manila, he initiated a critical audit of Moore's navigation tables. By 1798, en route to Spain, he refined solar and lunar position calculations. Finally, during a 1799 return to Manila, Bowditch completed major revisions for the first American navigational manual. Through these 4 historic voyages, he transformed the deck of a ship into a site of scientific rigor, proving that mathematical logic could conquer the pathless deep. In the late 18th century, mariners entrusted their lives to John Hamilton Moore's The Practical Navigator, yet Bowditch found the text barnacled with errors, over 8,000 mathematical inaccuracies. The most catastrophic was the 1800 leap year catastrophe, where Moore failed to recognize that 1800 was not a leap year. This simple lapse shifted solar declination tables by 23 minutes of arcade. In the unforgiving reality of the sea, that error translated to a 22 nautical mile deviation in latitude. As shown, following Moore's flawed math meant drifting dangerously off the intended safe route and sailing blindly into a deadly reef. A single error truly carried a lethal price. Imagine navigating the trackless ocean without an expensive marine chronometer. To find longitude, sailors were once forced to confront the celestial triangle, a nightmare of spherical trigonometry and complex calculus far beyond the average mariner's reach. Enter Nathaniel Bowditch. By performing the grueling mathematical heavy lifting himself, he re-engineered this barrier into a bridge. He distilled chaotic equations into elegant lookup tables, transforming hours of mental exhaustion into a few simple steps of addition and subtraction. Armed with only a sextant and Bowditch's grid, any sailor could now solve the lunar distance problem. It wasn't just a mathematical feat, it was the democratization of the stars, turning the elite language of the heavens into a practical tool for the common seaman. Nathaniel Bowditch lived by a bold principle: mathematical rigor, plus practical usability, equals democratized safety. He believed brilliant science is wasted if it remains locked within an elite circle. To prove this, he turned his fifth voyage on the Putnam into a mobile academy. He taught his simplified methods to the entire crew, ensuring that by the journey's end, all 12 men, even the ship's cook, were competent in taking lunar observations and plotting the ship's position. This narrative reflects a deep engagement with the history of science and the transition of theoretical knowledge into accessible public tools. By stripping away academic pretension, Bowditch empowered every sailor to master the stars, proving that true genius makes the complex universal. In 1802, the publication of the new American Practical Navigator established a definitive, new standard for the sea. This work replaced Moore's Practical Navigator, an outdated manual riddled with over 8,000 lethal mathematical errors. While Moore's text targeted only educated officers, Bowditch democratized the ocean by designing his perfected, rigorously audited tables specifically for the common sailor. Beyond correcting flawed methodology with simplified lunar distance lookup tables, Bowditch expanded the scope into a comprehensive maritime encyclopedia covering winds, tides, insurance, and law. This shift from basic routing to a holistic, accurate science secured its place as the Western Hemisphere's shipping standard for 150 years. Nathaniel Bowditch's intellectual masterpiece was his translation of Pierre-Simon de Laplace's Mécanique Céleste, the era's definitive yet daunting text on celestial mechanics. While Laplace often bypassed complex proofs with the dismissive phrase, "Thus it plainly appears," Bowditch knew those words hid hours of hard work. To bridge these mathematical chasms, he meticulously added thousands of step-by-step proofs, effectively doubling the original text's length. By transforming an elite masterpiece into a comprehensive pedagogical guide, Bowditch did more than just translate the heavens, he illuminated them, training the next generation of American astronomers. It's a powerful reminder that true scientific progress often depends on someone willing to show the work that others took for granted. While celebrated for mastering the seas, Nathaniel Bowditch also pushed the boundaries of theoretical physics. In 1815, by studying a pendulum suspended from 2 points, he discovered the intricate geometry of harmonic motion. He was the first to define the complex figures generated by perpendicular oscillations, decades before Jules-Antoine Lissajous would later study them. Although commonly known today as Lissajous curves, these mesmerizing patterns were originally dubbed Bowditch curves by the American scientific community. By translating the motion of a swinging weight into precise mathematical equations, Bowditch revealed a hidden symmetry in the physical world, proving that his intellectual reach extended far beyond the horizon of the ocean. In 1804, Nathaniel Bowditch brought his mastery of probability ashore, choosing to build American financial institutions over prestigious chairs at Harvard or West Point. As America's first actuary, he applied the same mathematical rigor used at sea to the volatile world of insurance. Leading the Essex Fire and Marine Insurance Company, he successfully navigated the treacherous risks of the War of 1812. Later, as actuary for the Massachusetts Hospital Life Insurance Company, he became a pivotal money manager. By directing maritime fortunes into emerging manufacturing hubs like Lowell, Bowditch proved that the logic of the stars could drive the engine of the Industrial Revolution. For Nathaniel Bowditch, mathematical precision was a sacred ethical duty, not just a scholarly pursuit. He recognized that while flawed calculations claim lives at sea, negligent accounting destroys the very foundations of society. To prove this, he launched an unsolicited audit of Harvard's finances, exposing over $120,000 in mismanagement and boldly demanding the president's resignation to force reform. His devotion to truth was equally philanthropic. He spent 1/3 of his life savings, $12,000, to self-fund the printing of Mécanique Céleste. By freely distributing this masterwork to libraries worldwide, Bowditch ensured that the plainly appearing truths of the universe remained a shared human inheritance, far beyond the reach of institutional decay. Nathaniel Bowditch's life reveals a singular, unifying pattern: the application of rigorous ledger logic to chaotic systems. This architecture of accuracy encompasses three vital roles. As the navigator, he tamed the ocean's unpredictability, giving sailors the tools for survival. As the astronomer, he demystified celestial mechanics, translating complex physics for a new nation. Finally, as the actuary, he quantified life's risks, establishing the foundations for American industrial capital. Centered on the absolute pursuit of accuracy, Bowditch held a profound conviction that numbers, when perfectly calculated and freely shared, possess the power to save lives and build nations. We conclude with The Enduring Ledger, a final testament to a legacy that refuses to fade. For over 200 years, the American Practical Navigator has remained in continuous publication, a vital tool now mandated aboard every commissioned U.S. Navy vessel. Bowditch's mission of charting the unknown lives on through the USNS Bowditch, a sophisticated oceanographic survey ship mapping the seafloor with multi-beam sonar. As his 1838 eulogy beautifully foretold, as long as the stars follow their courses and needles point north, the name of Bowditch will be revered as a guide over the pathless oceans. His obsession with mathematical truth didn't just solve the past, it anchored the future of navigation.